Okay, so now this is section 2 of the multiple choice section for the AP Calculus BC practice exam. So for this section, it's different from the previous section. There's less problems, there's only 17, in around the same amount of time. Well, actually less, there's 50 minutes. But the biggest difference is that this section requires a graphing calculator here. So I have my graphing calculator next to me. I don't have a program on my computer, but I'll try to make my calculations as clear as possible. So putting it in the calculator should be pretty straightforward. Um, my calculator is a TI-84 plus CE, but it should be pretty much the same for all the TI-80 series. So yeah, but if you have a different calculator, I guess you just you know uh, verse yourself in the functions before actually going into the test. So the general strategy again, there's 17 problems, 50 minutes. You should try to spend 3 to 4 minutes on each problem. Again, if you're stuck on a problem, just move on and come back to it later if you have time. Because getting a few problems wrong is fine, and if you don't have enough time to do it, just guess, because there's no penalty for guessing. But that's just basic stuff. So I have my timer here, and it's 50 minutes, and I guess we can just get started. Okay. Number 1. The function f, as shown in the graph above, is defined on the interval from -2 to 2. Which of the following statements about f is false? So, A, f is continuous at x equals 0. Well, uh, the limit is equal to the value, so it's continuous. So that's true, so it's not right. For B, f is differentiable at x equals 0. Well, it's not, because there's a sharp turn here, so the answer is B. But let's just go through the rest since we have time, and it's just better to be safe. Well, f is a critical point at x equals 0. Well, this directly contradicts this, right? Because if f is not differentiable here, that means this is a critical point. So this is wrong. And, well, this is an absolute minimum, because f is only defined from -2 to 2. So this is the absolute minimum. And the concavity does change, because here it's concave down, and here it's concave up. So the answer is B. Alright, let f and g be the functions given by f of x equals e to the power of x and g of x equals x to the power of 4. On what intervals is the rate of change of f of x greater than the rate of change of g of x? Well, this is pretty simple. We just want when f prime x is greater than g prime x. Well, what's f prime x? Well, it's just e to the power of x, and what's g prime x? It's just 4 to the power of x to the power of 3. So, when does this hold? Well, one uh, way to do this is just put it in your calculator. So if we go to the y equals at the top left, you can enter your y equations. So one equation we can put in will just be e to the power of x into y1. And for y2, we could put 4x cubed. And then we can graph it by hitting the graph button at the top right of the calculator. And then you can adjust your window if you'd like. But after we graph it, we can press the calculate. If you press the second button and you press the trace, you go to calculate, and then scroll down to click intersect, or number 5. And then follow the instructions. It tells you to find the first curve and the second curve, and you enter a guess for what you think the intersection is. I'm sorry if you guys can't see it, but it gives the intersection at x equals 0.831. That's all you guys need to know. And of course, sorry, yeah. So uh, the graph looks something like this, where this is e to the power of x, and this is e to the, 4x cubed, and this is the intersection. So, uh, and it looks something like this. So e to the power of x here is greater than this when it's below this value here, which is when x equals 0.831. So sorry. Yeah. So one bound is uh, from negative infinity to 0.831, but there's another bound up here because the exponential function grows faster than a polynomial function. So we know this value has to be contained plus something up here, right? We don't know what that is, but we don't need to know because the only answer with this is B. So yeah, this is a benefit of a multiple choice test. Okay, the graph of the piecewise linear function f is shown above. What is the value of the integral from -1 to 9 of 3 f of x plus 2 dx? No, this is just, uh, integration rules. This is just the integral from -1 to 9, 3 times integral from -1 to 9 of f of x plus the integral from -1 to 9 of 2 for dx. So first, what is the integral from -1 to 9 of f of x? Well, from the graph above, we can just calculate the area, right? So this part here has an area of -3. This has an area of -1. This has an area of 2. And this has an area of 4, right? So this combined area would be 6 minus 3 minus 1/2. So it'd be 5/2. And this is multiplied by 3, so it'd be, so this is 5/2, so 3 times this would be 15/2. And this part here, well, this is just 10 times 2, so this is 20, right? So this would be 35/2. Sorry, not, sorry. I can't use my stylus today, sorry. It'd be 55/2, sorry. So it'd be C, 27, 27.5. Let f be a function having derivatives of all orders for x greater than 0, such that f of 3 equals 2, f prime 3 is -1, f prime prime 3 is 6, and f prime 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 3 is 12. Which of the following is a third degree Taylor polynomial for f about x equals 3? Okay, since it's about x equals 3, we know that the term raised to the increasing powers is going to be x minus 3. So we can already eliminate a and b. Next, we just look at the values. Well, all of these have the first value 2, which is what f of 3 is. Okay, so all of these hold. What about the next one? All of these is -1, so this is also right. Now we look at the one which is 6, which is this one, right? Well, only this one has a coefficient of 6, so the answer is C. We can also verify the last one is 12, which is also C. The graph of f prime x, the derivative of the function of f, is shown above. Which of the following statements must be true? Number 1, f has a relative minimum at x equals -3. Well, we can test that. If the derivative goes from negative to positive, that means the graph of f, it looks something like this, right? Because it goes negative, it hits 0, and then it goes positive. So we know number 1 holds. What about number 2? The graph of f has a point of inflection at x equals -2. Well, a point of an inflection is uh, when, sorry, my stylus. The points of inflection happen when, sorry, points of inflection happen when the second derivative goes from -1, sorry, negative to positive, right? So, uh, if we take a look here, the derivative of the graph is 0, and the but the derivative of the graph stays positive, right? Because it's always going up, right? It's before this point, it's going up, and after it, it's still going up. So um, the point of inflection, it's not a point of inflection because the it's always concave up. Sorry, I don't know. I don't know what happened there. So number two is also wrong. Well, let's for number three. The graph of f is concave down for between x is for sorry between when x is between 0 and 4. Well, when x is between 0 and 4, the derivative of the derivative is negative. So yeah, it's concave down. So it's 1 and 3, which is e. So, sorry, that was okay. If the function f is continuous at x equals 3, which of the following must be true? Well, we know one. If something is continuous at x equals 3, that means the limit is x equals 3 of f of x equals f of 3, right? This is the definition of continuity. So we already know a is wrong because this is less than. We also know b is wrong because if the limit from the left to 3 is not equal to the limit from the right to 3, then the limit doesn't exist. Well, c holds because um, this here equals this, right? So we can substitute this into here, and yeah. And for d, the derivative does not necessarily need to exist. This is continuous, but there's no derivative here because it's a sharp turn, and this is pretty much completely irrelevant. So, okay, 84. For x is between negative 1.5 and positive 1.5, let f be a function with the first derivative given by this monstrosity. Which of the following are all intervals on which the graph of f is concave down? Well, it's concave down when the derivative of this is less than 0. So we can just solve for this, right? f of x equals, sorry about that, equals, well, from the chain rule, we just take the derivative of this here, which is 4x cubed minus 4x times e to the power of 4x, so 4 minus plus 1 minus 2, right? So we want to find the interval, we want to find when this is sorry, not sorry, no, no. Sorry, when this is less than 0. So we can just graph this, right? We can put this into the y equals the y variables. So 4x to the power of 3 minus 4x times e to the power of x to the power of 4 minus 2x squared plus 1. And then we can graph this. All right. And still waiting. All right. So, yeah, and then you can use the calculate, and you can find, if you press scroll down to number 2, you find the zeros of it, and you can set a left bound and a right bound and a guess. So I got a 0, if I can, I got a 0 at x equals 1, right? And so I can see that, well, sorry, I'll draw it for you guys, in case you don't have one. It looks something like this, and this is x equals 1. So that means between this interval here, between x equals 0 and x equals 1, it's negative. So there should be some interval from here to negative infinity, union some interval from 0 to 1, right? And the only answer with that is D. So again, it's another benefit of um, Sorry. This left bound doesn't have to go down all the way. It could, be wonky or whatever. But I know that this is in the answer. So yeah, the answer is C. All right, number 85. The fuel consumption of a car in miles per gallon is modeled by f of s equals 6 e to the power of s. Whatever. I'm not gonna say it, but yeah, it's there. Where s is the speed of the car in miles per hour. If the car is traveling at 50 miles per hour and its speed is changing at the rate of 20 miles an hour squared, what is the rate at which the fuel consumption is changing? Well, uh, yeah. So we want f. We want d over dt of f of s, where s is some function of t. So we can just differentiate this, right, with respect to t. So f prime s with respect to t is equal to, well, using the chain rule, we just differentiate this up here. So remembering that s is a function of t, we have s prime over 20 minus 2s s prime over 2400 times 6e to the power of s over 20 minus s squared over 2400, right? And 2s s prime comes from the chain rule, right? The derivative of some function squared is just 2 times a function times the derivative of the function. So well, they give us s prime and s already. Um, the car is traveling at 50 miles per hour, so s equals 50, because s is the speed, and s prime equals 20, because the speed is changing at 20 miles an hour squared. So we can just use this, plug this into our calculator. So we have open parentheses 20 over 20, which is 1, minus 2 times 50 times 20 divided by 2,400 times 6 e to the power of, well, 50 over 20 minus s squared, which is 400 over 2,400. And unfortunately, my answer is not on there. So I'm going to try again. I'll try to see where my error is. Um, sorry, give me some time. Right now I'm just plugging it back into my calculator to see if it was some error in me entering it. Alright, it's definitely not an error in me entering it. So I think it's an error in the function itself. So don't laugh at me, I'm gonna try to do it again. So f of s is this monstrosity, and we want the rate at which the fuel consumption is changing with respect to the time in hours. So we just differentiate this with respect to t. So f from s equals the derivative of the inside here, which is just s prime over 20 minus 2s s prime over 2400 times 6e. Well, this is the exact same result I had last time, which is um, unsettling. Um, I'm not too sure where my error is. I'm sure some of you watching are screaming, but uh, well, this is an example of a problem that you get stuck on. I'm not sure why, but I'll just circle it and I'll come back to it later if I have time. Okay, number 86. If f prime x is greater than 0 for all real numbers x, and the integral from 4 to 7 of f of t dt is equal to 0, which of the following could be the table of values for the function of f? Well, uh, for a, it's definitely not, because the integral for this one would be less than 0, because it looks something like this, right? Because it's less than 0, so it's definitely not a. B could be possible. C is definitely not possible because it goes from 6 to 3. D is not possible because the integral is 0. And E is not possible because it's always positive. So we're left with B. Let R be the region for the first quadrant bounded above by the graph of y equals the natural log of 3 minus x for x between 0 and R. R is the base of a solid for which each cross-section perpendicular to the x-axis is a square. What is the volume of the solid? Sorry if that was a little fast. If we draw it here, it looks something like this. Sorry, it looks something like uh, it's bounded from between x equals 0 and 2. Sorry, so it looks something more like like this or something. I'm not too sure. It doesn't matter that much, but it looks something like that, more or less. So uh, since the base is each cross section perpendicular is a square, the area is just the height squared, right? So just integrate from 0 to 2 of this value here, which is the natural log of 3 minus x dx squared, right? That's just the area. So we can plug into the calculator. We can go to math, which is underneath the alpha key. We go to math and we scroll down to number 9, fn int. We set the lower bound to 0, the upper bound to 2, and we just plug in the natural log of 3 minus x squared dx. And it gives 1.0291, so it's just b. Number 88, the derivative of a function f is increasing for x is less than 0 and decreasing is for x is greater than 0. Which of the following could be the graph of f? Okay, well, we know that there's a point of inflection at x equals 0. So that gives us a good starting point. It's definitely not A, it's definitely not B, because there's no point of inflection. Okay, we also know that it's concave down, it's concave up. It's increasing for x is less than 0. So it's concave up when it's below 0. When x is less than 0. So we can just test, well, this is concave down, right? E is concave up, and so we know it's E. D is concave down, so we know it's E. A particle moves along a line so that its acceleration for t is greater than 0 is given by this. If the t plus 3 over the square root of t squared plus 1. If the particle's velocity at t equals 0 is 5, what is the velocity of the particle at t equals 3? Uh, sorry. The acceleration is this. If the particles, what is the velocity of the particle at t equals 3? Okay, well, we can just integrate this. So we just want, okay, so the particle's velocity at t equals 0 is 5. So we don't, that doesn't matter now. We just want the change in the velocity between 0 and 3, and then we can add 5 to that. So what's the net change in the velocity between 0 and 3? Well, that's just the integral from 0 to 3 of a of t dt, right? And then we just add 5 to the end to get the velocity at t equals 3. Well, we just plug this into a calculator again. So go math, go down to f and int, the integral from 0 to 3 of this value, t plus 3. I'm putting it as x in the calculator because it's just more easier for me. So for me, it's x plus 3 divided by the square root of x cubed plus 1 dx. And that gives 6.71. And we add 5. So this is 6.71. We add 5. So it's 11.71. So it's E. Alright. If this series converges and an is greater than 0 for all n, which of the following must be true? Well, uh, for A, that could be a possibility because this is pretty much just the ratio test. So that could be a possibility. For B, uh, this doesn't have to be true because we could have a series just three. We could just a geometric series with a starting term of 3 and a common ratio of 1/2, right? So the starting term it'd be 3, 1.5, 0.75, and so on. So we know that converges, but these two terms are greater than 1, so B is wrong. For C, this just it's just impossible because an is greater than 0 for all n. So for D, um, like what? Um, it's it's just random. I mean, it could be true, but um, it it's not necessary because like an could be like wow, like 1 over. So I mean, it could be like 1 over n and then something else, which negates this n here. So this doesn't have to be true. I don't see. And for E, well, this is much stronger than this one up here because this is always less than this. So by the comparison test, this converges. So E is much stronger than A. Uh, and um, for the ratio tests, it doesn't require the limit to be 0. It just requires the limit to be less than 1. So this because again it could be a geometric series, right? With a common term 1/2. So the common term, this ratio is always going to be 1/2, but um yeah, it can still converge. So sorry, it's E. Sorry for the confusion. The figure above shows a graph of the polar curves r equals 2 cosine 3 theta and r equals 2. What is the sum of the area of the shaded region? Well, we only need one area, the area of one of these petals, and we just subtract it from a circle with a radius 2. So what's an area of these petals? Well, when is r cosine 3 theta 0? Well, uh, r cosine 3 theta is 0 when cosine theta 3 theta is 0. So cosine theta is 0 when, cosine alpha is 0. When alpha is equal to pi over 2 or negative pi over 2. Right? So cosine 3 theta is 0 when theta is equal to sorry, when theta is equal to pi over 6 or negative pi over 6. So we can put that into a calculator because this gives us one pedal here, right? Because cosine 0 is 0, so it's right here. And then once you go towards the first time it reaches 0, you come here. And if you go backwards from that, you go back to here. So it gives you this area of this pedal right here. So you just go to math again, go down to f and int, the integral from negative pi over 6 to positive pi over 6 of 2 cosine 3x, I'm using x again, dx is 2.094. And we multiply this by 3 to get 6.282, and we subtract this from 4 pi, right? Because this is the area of the entire circle. So 4 pi minus this value, sorry, 4. Well, I got a value that was not on there. Hang on. Sorry. I seem to be at another roadblock. Sorry, let me plug that back into my calculator. See if I honestly do not know. Again, um, let me. Yeah, again, I'm not too sure where my error was. Um, it seems. Alright, I'm just going to skip this one again for now and move on. The function h is differentiable, and for all values of x, h of x equals to h of 2 minus x, which is the following statements must be true. Number 1, the integral from 0 to 2 of h of x dx is greater than 0. Well, okay, first of all, if h of x is equal to 2 minus x, that means it's mirrored around it's mirrored around x equals 1, right? Because if we plug in x equals 1 to it, we just have h of x plus 1. We have h of x plus 1 equals h of 1 minus x. So it's mirrored around across this x equals 1. So because it's like sorry, uh, so because h of 0 would be equal to h of 2, right? So this is flipped over, and h of for negative 1, for example, is equal to h of 3, right? And this is also flipped over here. So it's mirrored over x equals 1. So number 1, the integral from 0 to 2 of h of x d of x is greater than 0. Well, this isn't given because it could be, negative like this, right? Number 2, h prime of 1 is equal to 0. Well, yes, because since h is differentiable, and um, it's mirrored. If it's going up when it reaches x equals 1, it has to go down. If it's going down, it has to go up. So 2 is correct. And number 3, the derivative at 0 is equal to the derivative of 2, which is equal to 1. It's not given anywhere. I mean, it could be like pointing down. It's not given, so it's only 2. Um, yeah. So we'll go back to the first problem that I so rudely skipped. Yeah, the full consumption of a car in miles per gallon is modeled by this, where s is the speed of the car in miles an hour. If the car is traveling at 50 miles per hour and its speed is changing at a rate of 20 miles an hour squared, at what rate is the fuel consumption changing? So again, this is f of s, and let me just write down it all. Sorry, where did my problem go? Here. So the car is traveling at 50 miles an hour. So s equals 50, and the speed is changing at 20 miles an hour squared. So s prime is 20. So we want to find the rate at which the fuel consumption is changing with respect to time. So the derivative d over dt of f of s is equal to the derivative of this 2400, which is equal to 6 times this part up here, which is just the derivative of s over 20 is just s prime over 20, because s is a function of t, minus the derivative of s squared, which is just 2 times s times the derivative of s, because s is a function of t again, so by the chain rule, that's how it is. So 2s prime over 2,400. Now times e to the power of the original value. So we just do the scan 6 times s prime 20 divided by 20 minus 50 times 20 divided by 1200 times e to the power of 50 divided by 20 minus 20 times 20 divided by 2400. And I got the same answer again, which is not good. Let me try to I'm not sure where my problem is. Right now, I'm just, trying to rack my brains to see where the issue in my calculations is. Because my final answer was 10.312, which is not an answer choice. So, um, I honestly don't know what my issue is. Yeah, I honestly don't know. Surprising. Oh, when I plugged in 20 for s squared instead of. So yeah, don't make that mistake. Um, Plugging in wrong values. Yeah, so instead I got uh, okay. So instead of plugging in 20, I should be plugging in 50. So I don't know how that, slipped past me. So I got 4.298, which is B here. So it's very, yeah. This it shouldn't be like that. And now we go back here. The figure above shows a graph of the polar curves r equals 3 cosine 3 theta and r equals 2. What are the sum of the areas of the shaded regions? I'm still pretty appalled at my mistake, but uh, well, another way we can approach this is we can just take the area of this entire thing at once. We don't need to take the area of only one petal. So what is the area of all this at once? Well, we can't go from theta to 2 pi because then it'll trace this out 3 times, right? Instead, we can just go from 0 to 2 pi over 3, or we can go from 0 to 2 pi and then divide by 3. So the first way I'm going to do it is just to integrate from 0 to 2 pi over 3 of this value here, and plugging it into the calculator, 2 pi over 3 to cosine 3x dx. Again, I'm using x. I get 4.180. So we just take 4 pi, subtract that from 4 pi, and we get 8.385. Now, that's not an answer choice. So I can try the second way, which is just integrating from 0 to 2 pi of this value. And remember to put your calculators in radians. Uh, that's my advice. Don't go into the test not knowing what mode your calculator is in. Uh, yeah, I silly mistake, but um, yeah, just remember to put your calculator in radian. So we can just do the second way from 0 to 2 pi to cosine x to cosine 3x, sorry, dx. And I got a very small value. So instead of doing it like this, I'm just going to do it by hand because I don't really need a calculator to do this. So this is just negative 2 over 3 sine 3 theta from 0 to 2 pi. So this is well, let me do it the sorry, I don't know why I cause it like subtracts it, cause yeah, I don't know why I did it that way. I think I just sorry. Again, previously I said that it was from negative pi over 6 to power 6, right? Because uh, cosine theta is 0 when theta, cosine alpha is 0 when alpha is equal to power over 2 or negative power over 2. Sorry about that. I'm not doing math that well today. I'm sorry. And so theta has to be between negative power over 6 power over 6. So now we can plug this into the calculator finally after changing the mode from degrees to radians. negative pi over 6 to positive pi over 6 of 2 cosine 3x dx, 1.3 repeating, times 3, which is 4, and we have 4 pi minus 4, 8.566, which is finally an answer. So if you're watching here, make sure, don't do what I did, and make sure your calculator is in radians, and also make sure that you don't do silly mistakes like I did, like integrating all the way to 2 pi instead of negative pi over 6. But now, if you're watching, check the time. I just check the time. We just made it. With 30 seconds on the clock, we made it. I didn't have any time to review other problems, which is honestly not good. But you should. Well, I say you should, but I didn't do it. But hopefully, um, you'll have the time to be able to review previous problems if you don't um, make as many mistakes as I did. Hopefully you don't. But despite making mistakes, I was able to finish all my problems. Because I skipped them when I couldn't really figure out my issue. So that's one thing to take away. Do not take away my mistakes. If there's two things you should take away, one is to skip problems if you're just completely stuck on them, and the second takeaway is to make sure your calculator is set to radians before entering this test, because I lost a ton of time, as you guys saw in this. But yeah, this is the section 2 of the multiple choice exam for AP Calculus BC.